Assalamu alaikum. So let's start the next chapter, chapter 8, the enhanced entity relationship model. So far we have been discussing the entity relationship model, ERD or ERM. The last chapter focused on that. In this chapter, chapter 8, we are now looking at some of the advanced features or advanced things that are in entity relationship modeling. And this is called entity relationship model, EER. The concepts in this chapter are basically the foundation is what we studied in the last time. This chapter focuses on concepts, additional concepts like classes and superclasses, specialization, generalization, union types, attributes, and relationship inheritance. So these concepts basically are used to model application more completely and more accurately. We can draw ER diagrams using the concept that we studied in the last chapter, but these concepts which are in this chapter, they represent more fulsome features of entity relationship modeling. In this, as you will study, there are some object-oriented concepts which you have already studied in object-oriented analysis and design. And also we looked at some of these things in software engineering under UML. So let's see what are these concepts. So the concept of subclasses and superclasses, you better know this from object-oriented programming and object-oriented analysis and design, that if you have an entity type, and in that entity type there are some specializations that can become meaningful subtypes. So for example, in the company database that we are looking at as an example for the last chapter, so in that if we have an employee, then that employee may be further specialized into subtypes like a secretary, an engineer, or a technician. So this becomes one type of specialization. So there could be number of specializations like this. In this case, we are seeing as one as type of role of employee, then as a manager, that employee who are managers, so those become subtypes. Then we can create another subtype, which is like if the employees are hourly employees or they are salaried employees. So all these concepts, they bring subclasses and superclasses concepts. So let's look at this this diagram. So in this diagram, if you look at employee, now employee has all those attributes which we created in the entity relationship modeling last time. So we have name, SSN, birth date, address. Now this employee can have some specializations. So one specialization could be in terms of their role, so secretary, technician, or an engineer. And then other type is, for instance, the salaried employee versus hourly employee. And then we have this subtype of manager. So not all employees are managers, but in case of, we will look at these notations that you are seeing here, a circle and a D and then this subset sign. So let's look into more details for this diagram. So each of these subgroupings, they hold a subset of employee entities. So there is an employee, and this become a subset, that whether they are an engineer or a technician or a manager or a salaried employee. So all of these are subsets. So these are called, each of them is called a subclass of employee. An employee is their superclass. So this relationship is basically a superclass subclass relationship. So employee as their superclass, and secretary as subclass, or a technician as a subclass, or a manager as a subclass. These are also called, if you recall from object-oriented programming, object-oriented analysis and design, these are also called is a relationship. So in this, or we knowledge representation terminology in artificial intelligence, we use that. So secretary is a employee, technician is a employee. So we have this is a relationship there. So now looking at these examples, it may be possible that an employee is part of more than one subclasses. So an employee who is also an engineer belongs to two subclasses. So a salaried employee and an engineer class. And if that person is also a manager, then we have three subclasses that are participating in this type of relationship. So a salaried employee who is also an engineering manager belongs to the three subclasses: manager, engineer, and salaried employee. So, but one thing to note is that it is not necessary that every entity in the superclass is member of some subclass. So it could be that employee is a manager, but it is let's say an engineer, but he is not a manager, so he is not participating in the manager subclass relationship. So in this case, if we now think about our entities, entity types, now we have all those attributes that are associated with the superclass. So how inheritance works in this case is basically that the entity that is member of a subclass, so an entity that is a member of a subclass, so for example, member of a subclass is job type. Now role type like engineer. So it inherits all the attributes of the entity as a member of the superclass. So all the attributes that are part of the employee entity type, they will automatically inherit it. And all relationship as well. So relationship of the entity are also then transferred or inherited by the subclass. So looking at this example, let's say a secretary or a technician or a manager or an engineer, they all inherit the attributes like name and SSN and other attributes from employee. So every secretary entity will have values for the inherited attributes. Now, during this process of defining set of subclasses and superclasses, one thing to note is that all of them, they are based on some distinguishing characteristics. So, for example, secretary, engineer, technician is a specialization of employee based on job type. So we are looking at this subclass, superclass, or subclass relationship as a specialization. So we have an employee, then it has a specialization based on the job type. It has a specialization on the base of basically method of pay. So whether a salaried employee or hourly employee, so this becomes another specialization. So this specialization is denoted by circles. So if you look at here, now employee has a specialization in, if you look at these circles, so these circles are showing specializations. Now this D means disjoint, that an employee will either be a secretary or a technician or an engineer. It won't be, that person won't be overlapping, so that role won't be overlapping. In some other cases, if O is there where it says D, then that relation becomes overlapping relation. So this circle is basically showing this that represent the specialization. So this circle now connected to the superclass, it is connected to those subclasses, and then this symbol, subset symbol, is there. Similarly, if you look at specialization of pay, then the salaried employee and hourly employee. So these three specialization of employee, one is the job type, second is the role, manager role or not, and third is the payment type. So all these are specialization. Now in reverse order, there is a concept of generalization. So in specialization, we start with broader concept and we go into specificities. So and then specific categories are technician versus here. So the generalization concept, we go the other way around. So several classes which have common features, they all are generalized into a superclass. So we have, for example, if we have car and truck. Now car and truck, although they have distinct features, like height of a truck is different than axle, and then the weight, capacity, and all those things are different. But some of the features are similar. They are vehicles. So if we generalize them, we basically say that both of them have a superclass, like a vehicle superclass. So let's look at this. Now, if you see, car has a price, car has a license plate number, car has a vehicle ID, car has maximum speed. Now with truck, it is more associated with number of axles. It doesn't matter with the speed in cases of truck. People are not more concerned. They are concerned about tonnage, how much weight capacity that truck can hold, vehicle ID, and price. Now these three things, price, vehicle ID, and license plate number, they are common in both car and truck. So we can have a generalization as a vehicle, as a superclass, where it holds those common features, and then those specializations, or in this case, if we look at in another way, we look at then car and truck. So now here you see again, now vehicle, and then it associates with car and truck, and then this circle with D distinct. So it becomes quite ambiguous when we look at generalization versus specialization, that which one is there. There are basically in books, in certain notation, some authors they use arrows, where they use arrows pointing specialized subclasses representing as specialization. But in this book or the material we are covering, and I think this is a better approach, because you don't know where you are starting, because it's all mixed up, whether you start with subclasses or superclass, or it's all mixed up. So rather than giving them basically arrows, we say that these are subclasses and superclasses, and then without arrows we use them. So if you look at this example, there are no arrows in this example. Now there are some constraints, like the constraints there are two constraints in relationship. Similarly, in specialization and one is around the disjoint versus overlapping. So I briefly mentioned that earlier, that if an entity is participating only in one of the classes, then if there's a possibility that the superclass will participate or in more than one subclasses, then it becomes overlapping. So we'll look at some examples, couple of slides down below. Second constraint is completeness constraint. Now this one is similar to what we looked at in relationship, where we said there was a partial optional relation, basically we call it, there is a relationship between two entities, and now the participation is whether optional or total. So if it is optional, then that here it says partial, and we use single line. When it is a must partnership, total partnership, then we use double line. So the concept is quite similar to what we studied earlier. So in this case, we have two type of constraints for disjointness, and the second is overlap. So let's look at this example. Now here you see that employee would be either a secretary or a technician or an engineer. It won't be the case that an employee is two of them or three of them or different, that together he is also serving as a secretary and also serving as a technician. It won't be the case. But if you look at this example, this is now an overlapping case, where a part could be a manufactured part, or it could be a purchased part. So, and it could be both. So in this case, if you look at here, there is one thing that you note is there is single line between employee and D. So employee, there may be a case that he is none of them. So he is not a secretary, he is not a technician, he is not an engineer, he has some other role which is not defined here. Then that employee won't be participating in any of these subclasses. But in this case, a part number and description, it must be it must be a manufactured part or a purchased part or both. So it could be the case. So in this case, we have a double line, and also we have O in between. So this double line versus single line I showed you earlier. So we have four type of now specialization generalization cases. We have disjoint total combination, we have disjoint partial, overlapping total, and overlapping partial case. So let's look at some other. So how do we basically show these partnerships? So one case is that we go with hierarchy. So hierarchy is like a tree structure. So you start with something and then you have only two options there. From next you have two options. So you go with a hierarchy or a tree option. So hierarchy has a constraint that every subclass have only one superclass. So that would become a hierarchy, that every subclass has only one parent, one superclass. So this becomes a tree structure. There is another structure which is a lattice structure. So in lattice structure, a subclass may have more than one superclasses. So that would become multiple inheritance. So in this case, if we have engineering manager, now it is coming from salaried employee, it is coming from engineer, so it is, and it is also coming from manager. So we have engineering manager as a lattice with sharing subclasses concepts. So in lattice structure or lattice hierarchy, that particular subclass inherit attributes not only of its direct superclass, but also of its ancestors' superclasses. So all the way to the root class where the root is there. So we look at some of these examples of specialization. Let's look at this. So if you see there is a person, now person is participating in a relationship which is overlapping. It could be an employee, it could be an alumnus, and it could be a student. Now, if a person is a student assistant, then look there, you have basically multiple inheritance that is also coming from employee and also coming from student. So we have two superclasses in this case for student assistant. So this this shows basically that a person is how a student is assistant is associated with person. But in case of student assistant, it would be either a research assistant or a teaching assistant. That person won't be both at the same time. So let's union types. Let's look at union. So there are some other material that you can cover, but these are the basic concepts of enhanced entity modeling. Now union type, so far all the subclasses and superclasses relationship that we have a single superclass. When we have a shared subclass, is that there is more than one distinct superclass-subclass relationship. So in that case, we use is category or union type. These type of subclasses are category or union types. So for example, now look at an example of vehicle registry. Now for vehicle registration, if you have a vehicle that is owned by a person but loan is given by a bank or a company, then you can think of there is a union type of category in that case. So let's look at this. Look at this. So a vehicle, a bank, person, and company. Then we have an owner which owns this registered vehicle. Now this relationship, we can see there is a union between the bank, person, and company, and that union is then associated with owner, and that owner then owns a registered vehicle. There are a few more examples. So in this case, if you look at person, student, faculty, and instructor, researcher. Now an instructor researcher could be a graduate student, and if the person would also be a faculty member. So we have this relationship in this case coming from more than one entity types. If you look at this one, so we have an employee and we have a person and a corporation, then owner that owns an aeroplane. So all these examples shows how this concept of basically union types and superclass, subclass, specialization, and generalizations are used in ER diagramming notations. Now these can also be alternatively notated by notations used by UML class diagrams, which you have already studied in other courses. So if we look at similar, the same ER diagram in UML class diagram approach, then it would be something like this. So just to give you a brief overview of this, in this case, the general conceptual modeling, modeling concept, we have classification and instantiation, aggregation and associations, generalization and specialization, identification. And then in terms of coordinates, we have cardinality, minimum and maximum, and coverage, total versus partial, exclusive versus overlapping. So these all concepts you have studied now in modeling concepts. There is another concept of ontologies. And in ontologies, basically it's a specification of a conceptualization. So if we look at specification, then it refers to the language and vocabulary, the data model concept used. And conceptualization is the description of the concept of a particular field of knowledge. So for RDF, the resource description framework, and these all are used in semantic web. But the basic is behind that is basically also the concept of databases. So if you want to study more in this area, I'm happy to discuss in what is used in semantic web and how RDF is used to structure the data. So just to summarize, these some of these last few slides are a summary of what we have discussed in this chapter 8. So this was a brief, basically, overview of some of the enhanced level approaches in entity relationship diagram. So I encouraged you to basically learn these as well, but the basic ones which are in chapter 7 that are very important in terms of the foundational concepts in ER diagramming. So I think I leave you here with the lecture so far, and please review this along with the slides and read the chapter book, which will help you to understand the concepts in a better way. Assalamu alaikum wa rahmatullahi wa barakatuh.